Okay, we're now going to look at a special type of discrete distribution, and this distribution is known as the binomial distribution. For a situation to result in a binomial probability distribution, it must satisfy 4 criteria. So we're going to have 4 criteria right here that it must satisfy. And then we're also going to talk about what the random variable is. So the 4 criteria, the first one is that there must be a fixed number of trials. So we'll see here in a minute how the situation you can only be doing something a fixed number of times, and you have to know what that is. The trials must be independent. Each trial must have 2 outcomes, either success or failure. Sorry, I think I spelled independent wrong. And the probability of success must remain the same for all trials. Okay, so you have to have a fixed number of trials. It'll tell you you're doing something 10 times or 50 times or whatever it is. Each trial must be independent. So if you're, say, picking a card out of a deck or doing something, you'd have to do it with a replacement. Each trial can only have 2 outcomes, either a success or failure. And your probability of success must remain the same each time. And the random variable that we're going to keep track of here is the number of successes. So we're going to go through some situations and decide, are they binomial or not? So the first one says, roll a 12-sided die 8 times and record whether or not a 10 was rolled. Okay, so let's go through the 4 criteria. The fixed number of trials, we have that because it says 8 times. Are the trials independent? The answer to that is yes, because when you're rolling a die, the previous rolls do not impact the next roll. Here we do have, even though it's a 12-sided die, we do have 2 outcomes. Either it is a 10, so we'd call a 10 success, or it's not a 10, which would be our failure. And there would be the same probability each time because you would have the same probability of getting a 10 each time. Okay, our next situation says, you survey 10 random adults. Do you regularly watch the 6:30 evening news? So our fixed number of trials are the 10 adults. We're assuming that it's independent since it's random. The 2 outcomes would either be yes, you watch the news, or no, you don't. And we're going to assume that each person has the same probability of watching the news. So this would be yes. Situation 3 says, survey 10 adults. Which news do you prefer? CBS, ABC, NBC, CNN, or Fox? Well, we do have a fixed number of trials. We could assume that they're independent, but we have too many outcomes. There's a lot more than just 2 outcomes. There's 5 different things they could say here. So we'll say no. Too many outcomes. The 4th situation here says we have a 3-color spinner. So let's just say it's red, blue, and green. Count the number of times it takes to get gets red 5 times. Well, again, this would not be binomial. So we could just say no, because there's not a fixed number of trials. So it could take us 5 times to get red 5 times. It could take us 50 times to get red 5 times. Since we don't know how many times it will take, we don't have that fixed number of trials. Number 5 says record the weight of 7 newborns born at a particular hospital one day. Well, this is not binomial because there's not 2 outcomes. Number 6 says quality control personnel at a light bulb factory randomly pick a sample of 25 newly made light bulbs and record the test of each light bulb. So this is binomial. We have the fixed number of trials. We have 25 that we're doing. Either the bulb is good or bad. Since 25 light bulbs is probably very, very small compared to how many light bulbs they're making, their sample would be big enough that this would be considered independent. And we would assume that from the process, each light bulb would have the same probability of working. Number 7 says it's a survey of 1,000 kids, and they're asking, what's your favorite color? And if you know kids, you know they probably all pick different, slightly different colors. So again, this is not binomial because there's more than 2 outcomes. And number 8 here says 10 red marbles and 5 blue marbles are in a sack. 15 people each draw 1 marble from the sack, and the results of the colors are recorded. So here we're not quite sure. It depends on whether the marbles are put back in the bag or not. So we're going to put maybe. So if it's with replacement, so if they're putting the marbles back in the bag each time, then we would say yes, because then there'd be a fixed number of trials, the 15. It would be independent with the replacement. There's 2 outcomes, either red or blue, and the probability of getting a certain thing would stay the same. If no replacement, then the answer would be no, because the trials would no longer be independent. So that's kind of the thinking of how to think through, is a situation binomial or not. So just remember, it has to fit those 4 categories. There have to be a fixed number of trials. The trials have to be independent, only 2 outcomes, and the probability of success must stay the same in each trial. Now, if something has a binomial situation, the reason we care about studying that is that there's actually a formula to help you find the probability of success. So here's the probability for the binomial formula. The good news is our calculator actually has a function that will find that for us. And it actually has to do with combinations. So the binomial formula is used to find the probability that there will be X successes out of N trials. So here are all the variables that go into it. N is the number of trials. P is the probability of success out of 1 trial. X is the number of successes out of N trials. Q is the probability of failure, which would be 1 minus P. And N minus X is the number of failures. Now on our calculator, we're going to have a way to put this in, and it does this formula for you. You just have to put in N, P, and X. So if you hit, we want this distribution, so you're going to hit second, and then vars, and we're going to go down to where it says Binompdf. So A. So then you'll put in the N, so if you hit enter. Now, yours might bring up a menu like this where trials is your N value, then you'll put your probability, your P value, and then your X value. If it doesn't come up with that little menu, it'll just bring up the word Binompdf and a parenthesis. You'll put the N value, comma, then the P value, then the X. I always tell students to remember it's in alphabetical order. And just make sure you put it in that order with the commas. So we'll do some examples here. So number 1 says, given the number of trials 10 and the probability of success is 0.5, for part A, find the probability of 5 heads out of 10 flips. So we're going to do Binompdf. The trials here is 10. Our p-value would be 0.5, and we want to find the x-value for 5 flips out of 10. So see, you can see that it actually put in there Binompdf npx. So enter. So here we'd get 0.2461 if we round it to 4 decimal places. So 8 heads out of 10 flips. The only thing here is going to change is the x. The n is still 10, and the p is still 0.5. So we go down to Binompdf. Our trials is still 10, our p is 0.5, and now we want to know what's the probability of getting 8 heads. So this will be 0.0439. Okay, now here we're going to look at a different situation. So here it says, given the number of trials n is 32, and the probability for success for one trial is 0.35. So that's going to be our n and our p, and then our x will change each time. So here our trials now, we have 32 trials. Our p now is 0.35, and our x for the first one is 11. So we see our first one is 0.1468. Okay, so remember, if you were just doing this, so if you had the Binompdf, you would put your n first, 32, then your p, 0.35, and then your x, 11. And for all of these next ones, you would only have to change that last number. So for the next one, we want 8 successes, so we're just going to change the x to an 8. So there we see 0.0766. For C, we want 20 trials, so we're going to go back to the exact same thing. Sorry, 20 successes. We still have the same number of trials and the same probability, so the only thing we have to change is that x value. Now, this is scientific notation. So this e to the negative 4, so if we have 9.773, say 1, e to the negative 4, this tells us we're going to move the decimal 4 places to the left. 1, 2, 3, 4. So it'll be 0.0009, say 8. And the probability of 0 successes out of 32 trials, we're going to put 0 in for x. So again, scientific notation, so we're going to move that decimal 6 places to the left. So we'd have 0.000001. Now, one thing that's kind of cool is if you put in here, if you went to your y equals, so hit y equals, went to distribution and down to the Binompdf. And so let's do it for this situation. We're going to put the number of trials, the probability, and then we could just put x, because that's what we're going to allow to change each time. Put paste. So that's going to put it in y equals. Oops. So I have that in the y equals. Now if we make sure our table is on auto, and we're going to start it at 0, then if we go to the table, it will actually make the distribution table for you for any of the possibilities. So this would go all the way up to 22, but so we could go to 11, and we'll see that that gives us the same probability that we had before.